We are elongating the amino acid chain using the manual solid phase peptide synthesis. So I have conjugated the amino acid. So now it's the time to check whether the conjugation has done or not. For that reason, what I am supposed to take, I have taken the 10 microliter of TNBS. It's nitrobenzene sulphonic acid, and set in the 10 microliter. You can see I have taken the 10 microliter, and I have put inside the tube. Then now I've taken the resin a little bit in the by dipping here, and I insert it here inside this, right? So I can see that there is no change in the color. You can see that there is no change in the color. But you can see the color. So I was talking that how could you differentiate that your coupling has done or not? You can see the color here, that one region is seen as a pink color and another is the yellow. Yellow is due to the TIPA only. You can see yellow is the TNBS, right? And the region color is, you can see that the white color is there. Yellow is white, right? So you can see differentiate that the region supposed to be pink color, right? Now you can see, right? But here you can see that we have kept it for long run, but there is no change in the color. Okay, the resin beads are seen as a the resin beads seems as a no red color is seen right now. So basically the difference is that actually I am not showing you able to that close view mine. The resin bead. Why this camera is not clear? So you can see that one, right? That this much of difference can be visualized, right? Now, so now what we'll do now, we'll add a little bit of DIPA, okay, over this. So what is going to happen, we'll see if we'll add DIPA there, right? If we'll add DIPA, what is going to happen? But without DIPA, there is no color is there, right now. So I kept DIPA here because opening a big bottle all the time is not good for DIPA. Okay, take it and let's add this. So I can add the DIP also, but I didn't find any change in the color, right? Instantly the color change would be there if the deprotection mean NH2 is free. But we have done the coupling. So I want to see that whether that coupling has done or not. So now I can see that you mix it properly like this only, right? You see, I'm mixing this, but I can't see the color. Okay, so the color you can see that the color of the resin bead here and here, that there's two things are different, right? So the color of the resin bead, you can see one is pink color or red color somewhat, and another is still yellowish white. Okay, there is no change in the color. Okay, is it clear? I think everyone is clear. Okay, so this is your TNBS test. Okay, for the this is the TNBS test for the amino group, whether amino is coupled or free. If you feel that that amino is not, sir, okay, so let me take all the things, because this is GIP only I have added, so I can use it. So where I have kept this thing, yeah. So let me take one more old one. So you can see that so if you feel that the resin color is red, so you have to do again coupling, right? No, that means a free amino group is there. You have to check it. You have to check it clearly, nicely, whether the coupling is success or failed. So to see this, what we will do now, we will add a little bit of DMF also, right? The volume solution would be increased, so we can now analyze that one. Let me add. So now I will add into this DMF right now. So now it is very big volume, so resin are floating here and there. So what it indicates, let's see. Because sometimes what happen, no, the DIP color also shows. Okay, so it's very difficult to identify. Okay, so for that reason I've added here that your DMF, so dilution can take place, and I can see that the resin beads are not color. Right, resin beads are not color. Similarly, I will add here DMF and you will see that one, right? This is the after piperidine DMF one unit deprotect, no, the color is this, right? So still you can see that the beads are colorful, I think. Perhaps it visually, yeah, you can see so nicely. This yellow color is due to the DIP and TNBS, but the resin beads are how pink color it is seen. But in this color, there is no color, right? You can see the difference. This is the difference basically, right? So you can see that this is still no color is there, huh? And this is color. So it indicates that coupling has done. Okay, so now it is the time to do deprotection. So for the deprotection of piperidine DMF, okay, this Fmoc, what we will add here now, we will add this 20% piperidine DMF. Okay, so let's see, because it is having a very bad smell, and I am doing this experiment below the exhaust only. Why? Because the smell is very bad. The DIP, sorry, TN, your piperidine. gonna add this over there. Near about 5 to 7 ml of, I've added the 20% piperidine DMF. Okay, 20% piperidine DMF I have added here. I have kept it aside for study purpose. Okay, so now I'll close it and I have to pass the nitrogen. So this is the nitrogen cylinder basically. Now so you can hear the sound. Okay, done. Right, so you can see this thing will be done for near about 10-15 minutes. And this bubbling will deprotect the, in the presence of nitrogen, it will deprotect it, right? Deprotect the Fmoc from the amino group. So perhaps it is clear to all of you that how we have done the TNBS test. Okay, so 10% TNBS is basically used. So 10 microliter of TNBS with 90 microliter of DMF, you dissolve it and keep the solution ready, stock solution, and from there take 10 microliter whenever there is you want to test the free amino group, because solid phase peptide synthesis is this is all about, right? So this procedure, the deprotection of Fmoc, will be continue like this for 4 to 5 times, right? Because you know that Fmoc has to be deprotected nicely, then only we can conjugate one more amino acid. Okay, okay, take care. Watch this. If any doubt is there, you may comment in the chat box. I'll answer it. Fine, thank you. Bye.